we go. Right. So even Chrome can fail. Anything can fail in software, really. Okay. A little bit about myself. I have had an interesting life. So I grew up in South Africa. I've lived there for 33 years. And then I moved off and I went to work in the UK. And I've been there for 16 years, roughly. And then this year, I made another change. So this year I moved to Andorra. And at least there's normally one conference I can come to where people know where it is. You can go to many other places and they wouldn't know. I phoned someone in the UK the other day and they said, where do you live? And I said, Andorra. And they said, which country is it? It is a country. Anyway, so we made that move. We started a small little company there. But we also made a move for a lifestyle, so it is a pretty beautiful place. If you've been there, then you would know. If you haven't, then I would advise you to at least go there once. And probably should actually go there twice, once in winter and once in summer. So that's pretty much where I work from. That's just some of the scenery over there. So I would hope to be here many times in the future. Okay. So you can get me on that email address. I have a couple of email addresses, but that one is always safe. And the same thing, you can get me on Twitter in the same way. Actually, if you just Google for YSB33R, you would probably get hold of me. It is relatively unique, and I think there's probably only one hit for somebody else on it, but it's generally me, so you can find out all my dirty secrets. I've been involved with a couple open source projects, and you will notice there's a lot of Gradle on there, because this is primarily one of the biggest things I do. And although today's talk is not about Gradle at all, I'll just mention it for a little bit. I've written a whole number of plugins in it, including one for the Myra language on the JVM, which I guess once again, some people might know what it is, some don't. I've also done a lot of work for running JRuby on the JVM. Not actually really on the JVM, but actually run it with Gradle on a JVM, so you can actually pull a lot of things in. And one of the reasons we did it is because we wanted to make sure ASCII Doctor builds better under Gradle, and that is primarily one of the reasons why I actually can build it quite well now. And the other thing is ASCII Doctor is actually a Ruby-based project. It runs in JRuby, and it actually allows us to pull on any gems and anything. So if you've got a specific custom extension for Ruby that you want to plug into ASCII Doctor, you can actually run it in the JVM as well. That's because of the work we've done there. I am the author of GROOVY VFS, which I will mention later in this talk. I've also started a new library called GRADLE, which helps you to write plugins a lot easier for Gradle. And then finally, I was writing a book for LeanPub, and I did not want to write in Markdown, because ASCII Doctor, actually, we use ASCII Doctor. I can see one there. Right, so only 2 people write documentation as well. Okay, maybe not. Maybe some people use Markdown or something else which we won't mention. But I didn't want to write anything in Markdown because ASCII Doctor is much more powerful. So I actually went out and wrote a whole backend for ASCII Doctor so you can publish to LeanPub from ASCII Doctor, and it converts everything to Markdown. Made my life a lot easier. And it's there if you want to write a book for LeanPub as well. Another thing that I do is I run this Twitter account called Daily Gradle. If you use Gradle for building stuff, then you can follow that. I tend to tweet once a day with a tip, although lately it hasn't been that periodic, just because we've just simply been too busy. There's a lot of things when you move house that happens, so, and plus you still have to do some work that brings in money, so it does cost a bit of number of tweets, but it is there, and you'll be happy to follow that. And I've actually, as I mentioned, I've written a book. That's one of them. It's out on LeanPub, which you can get. You can also get the second volume, which isn't finished yet, and it's all about actually writing stuff for Gradle, or writing plugins for Gradle. Okay. Just one last thing before we move on to the real technical stuff. This whole presentation has been written in ASCII Doctor as well, and we just use ASCII Doctor Reveal.js to style it. And you can do it much better than I've done if you just change the CSS. I don't really know CSS very well, so the default one tend to work for me, and I just tweaked a couple of things. And it gets built by GRADLE, and it uses a couple of plugins, just do a couple of other things just to make my life a lot easier. And for me, doing kind of things like that just helps me a lot because it makes things simpler in life. So on to technical things. A couple of years ago, I worked on a project where we had to move a lot of files around. And this means we had a typical, in an old corporate style, there's a lot of legacy systems, works with different protocols, etc. And we had to pull files from one system, move it across, and you had firewalls in place, etc. So my interest in this really started there. But before we even get to some of the systems we use, I just want to talk some goals that I actually have. Some of them I realized today, some are not realized, but they are actually important, and they would probably be important for you too. So the first thing is I actually wanted to transfer files from one system to another one. Like I want to go pick up something from an SFTP server, and I want to push it to an FTP server, argument's sake. It could be something different. I want to push it to S3, I want to collect it from S3 and put it somewhere else. There's a lot of that stuff that happens today, and if you do a lot of DevOps, those things are quite important. But I don't want to write a lot of code to do this. Right. If you've written stuff that pulls up from FTP with Java, you know there's a lot of boilerplate involved. So I want to use systems that, or libraries that's going to make my life a lot simpler. Also, I want my code to be as similar as possible, irrespective of the protocol, the scheme that's in use. I think that makes sense, right? Because it's something that's known. If you want to copy from A to B, you just want to effectively copy. You don't want to have this bulk sets of code to do this. So, two goals. Firstly, we've mentioned that, and then if I can change, don't have to change too much code. Actually, if I was as simple, I just want to change the URL, basically, and the rest of the code should look the same. If I can achieve that, that's great. And then I want to use some flexibility in terms of the third-party libraries, because you cannot write all this code on your own, so people are going to use different libraries to do stuff. So for instance, you want to do FTP, you've got a couple of options. You're going to do HTTP, you've got a couple of options. And when I actually have to use third libraries to do this, I don't actually want to guess which one to use. So you want this to be as simple as possible. If you write these kind of things and you want to give it to other people to use, they don't want to guess, so you want to make it simple. And then I want to be able to dynamically add more protocols, file systems types, etc. You don't want to have to recompile it, so you just want to do, typically in the JVM world, you just want to drop something in, and if it's on a class path, it should get activated, because that's nice. And then I don't want to be encumbered by linkage issues. So I want to have this kind of dynamic linking available for most kind of licensing, open source licensing at least that's out there. That should be fine. Although we're lucky, most of the things we use tend to be Apache, some of them is not. If you're going to use JSIFs to do SMB, it's LGPL. So you can't code against it directly, you have to dynamically load it. So this is quite important. That's one thing we quite tend to forget. So, who's used Commons VFS? No one? Okay, so the Apache Commons VFS has been out there for quite a long time. It's an Apache Foundation project, and it's licensed against Apache v2 as well. And it supports a number of protocols. And it does nice things as well, not just protocols, it does archives and things like that. So you could basically look into a zip, select a couple of files, and copy it to another server if you want. And it makes it relatively simple. It actually has an SMB implementation, but they don't publish it because under the Apache Foundation license, you cannot actually publish anything that links to something that's not an Apache license. So they have the example code, it just needs to give it published. So you have to pull it out, and you have to build it yourself if you want to use it. Fortunately, they don't have other nice things. They don't have CPIO support, which we sometimes required for some things we had to do, and it doesn't have NFS support, because sometimes you want to build stuff, you want to copy things, but you don't want to set up a whole infrastructure to pull stuff. You can do it with Docker, but Docker can be an overkill for if you just want to pull 2 files from like an NFS server. So you want that kind of support. So this is pretty much what Apache Commons VFS came in. It does have a number of protocol support. It does miss a few. Typically, how you would use it is you would just create a VFS manager and just assume that source dir is a normal file object from Java. Create a URI, create a file object, and then you can also, for instance, use another URI. So I want to say, I want to copy this file, I want to put it in a RAM file system. And I want to eventually going to put in that RAM file system. Let's call it just example. So with VFS, you pretty much have to resolve these things, create what we call file objects. And then once you have the file object, you can just say create folder, which is pretty straightforward. So it actually goes to that RAM file system and will create a folder underneath it. And I can just say, copy everything from my source, and it's got us like little selectors, which says, select everything you find in that directory and below it. So you can go read about it later, but that's pretty much what VFS will give you. So it already gives you a lot, it takes a lot of the heavyweight code away from you, it makes it a bit simpler. But it serves you with a couple of concepts. The one thing is a file system manager. And all of these kind of concepts are important because we actually get to NIO, you'll actually see these things go across. So the file system manager basically manages a whole collection of file systems. That's what it says. So it's the thing that actually allows you to load different kind of file systems, and to a great extent it will actually do some of these things behind the scenes for you. What it actually does, the way it works, it looks for certain jars to be on the class path, and then it will enable certain file systems based on that principle. And then it has the file system itself, which gives you access to like resolve files, create directories, etc. And the file object itself is the thing that you would normally, effectively closest thing in Java is like the file itself, which we call the file class. So it will allow you to do things like get relative files relative to this one, copy data, or move the file around, etc. And then you obviously, different file systems are going to have different kind of options. So for instance, if you're going to work with FTP, you might want to say all my copies have to be active or passive, or you might want to put some security options on there as well. So it uses the same kind of metaphors it was used to normal kind of hard drive file system, but as you even know with different kind of file systems you have, whether it's HFS or ext3 or NTFS, etc., they also have a couple of own options. So the same kind of things for any kind of remote file system. This allows you to actually set specific options for a different file system. But the problem with this is it requires a little bit of magic. The first thing is there's no standard naming, and for instance, if you want FTP, you have to know you have to drop comments net onto the class path. And the same thing is the same for HTTP, or if you want to use any of the archives. And some of the things currently is out of date. Like if you want to do web dev, you still have to use Jackrabbit, uses an old version of Jackrabbit. And it generally web dev doesn't, for instance, doesn't work very well anymore. And if you, it is very, very hard to replace it. So that's some of the drawbacks it has. I mean, it can solve a lot of problems for you, but it's pretty much where I started from, is actually using Apache VFS. But when we did our work, I actually said, this is still too much boilerplate. So we wrote a thing called, GROOVY VFS, and it's out there, you can use it today. It's obviously, it's Groovy based, but it makes things a lot simpler. It's still Apache v2, and it adds S3 and SMB support, so it's very easy to copy things into Amazon, etc. And it sanitizes some unexpected behavior they find in Commons VFS. For instance, it's got normal Commons VFS. If you copy a file onto a directory, and the directory has the same name, it throws the whole directory and all of everything below it away, and it puts the file in place, which is not something you would expect. So it takes that kind of behavior away, and it makes it much more sane. So just as an example, what we actually do with Groovy VFS, that's the code. If you write in Groovy, for, if you don't, I suggest you still actually learn it because it's useful for many things. You can see now suddenly it becomes a lot simpler for me to write things. I just want to say, create this directory on my RAM file system and copy from my source files into my RAM file system, overwrite anything that's there, and do it recursively. And probably if you saw that, after a while you would have figured it out yourself. So this was our next step, actually make codes a lot simpler. And as I said, it says it's easy to add providers. You can just add once, it's got a DSL to do this, etc. And it shows you the intent. The problems it has is it inherits all the problems generally that Apache Commons VFS has. And the life cycle of file objects from Commons VFS is not really clear to the user. Because normally it will close things in the background, and sometimes you don't care about it. The moment you start working with FTP, which opens a data channel per transfer, you start to get problems. Because if you have anything that has got any DOS protection on it, the moment you've got more than 3 connections open, it just refuses to give you any more connections. So you have to manage that explicitly, and once you start doing that, your code starts growing and become a lot less easy to read. So this is where we actually started, and then in JDK 7, and I think some of the people actually of Commons VFS was part of creating this JSR. It provided a lot more. It provides you a whole new framework, and this is actually really where the journey starts now for us. And the only thing about this is there are no providers in it. There's an example of zip in the sample files that you can get, and then the other thing is obviously it provides access to the local file system, so pretty much the file scheme. Now, if you've used paths, you've used NIO2, and if you know that if you actually want to start using this, got some other things like data channels, etc. So we're just going to focus on the file system part of this. So once again, it's got a couple of concepts. As I said, path is the one you probably know. It just represents a file or a folder on a system. It can be presented by a URI. You can resolve other paths relative to it, etc. And once you have that, you can access specific things on the local file system, for instance, doing symbolic links and things, which you couldn't do previously. It has the file system provider, and this is one is now slightly different to what you will get with Apache Commons VFS. It actually loads it based upon a specific single scheme, and it creates channels for you. And then it has a file system as well, which you can get from the provider. And once you have a file system, you can get back to the provider. It allows you that kind of abstraction. So, typically a file system in it would be something like this. You'll provide it with a URI, and here we have 2 FTP URIs. One is server 1, other one is server 2. They're the same scheme, but they are different file systems. That makes sense because you would generally, if you have, especially on a local system, you could start some, like Linux would actually allow you to join anything that it looks like a single file system. That's the abstraction, but effectively your remote SMB or your NFS is a different file system. So this is one thing to keep in mind, and this also plays a role later. Let's just have a look at actually what kind of code you write. So for all of this, just assume that we're going to import everything from that specific package. So it just makes it a lot simpler. I'm not actually going to show that anywhere else again. That's just the default assumption. So typically where you can go, you can use paths. You say, I have some kind of URI, for instance, like RAM example 1 file text. You put it in there, and it gives you a path back. And just by example, all of these code snippets you see here are all actually tested as part of building the documentation. It's one of the advantages you have actually of combining a couple of things like GRADLE with ASCII Doctor and your code, because you can do this kind of things. You can just pull it in a little bit. So for me, that's nice, because I know the examples I'm showing you don't have bugs in them, or at least they compile. Okay, so it has the concept of a default provider, which in most cases simply give you access to the file system. And you can, in that case, just say, give me the default, and here's a path. I have a folder name, a string, and I can give it a file name, for instance, and you can give that back to me, and then I can work with a path. Now, although this is effectively a great framework, you'll soon see that the code starts exploding. Because if I want to load a file system, firstly what I have to do is I have to create a map with a set of options. I have to create a URI, and then I have to tell it to load this. Now those options are absolutely arbitrary. You can put anything into it. It's up to the specific file system to interpret it. Okay. Which is great in the sense that it gives you the very generic abstraction. But it also means that you have to document stuff quite well so that people know which options you can use. And it's up to the file system provider to actually, or the implementer of it, to decide whether they can ignore options they don't know or whether they're going to throw an exception. But that's not a part of the specification, so you can get either behavior. And so that was fine. The other thing is, for instance, if I have FTP, I said you could do something like that. I can say I want to use passive mode, and I can give it a Boolean, and then I pass it in, and then that specific FTP provider then have to know that for all connections, so does it have to use passive mode instead of active mode. Okay. Now, once you get into reading from a resource, it gets more complex. I've written this one in Groovy because if I had to write this one in Java, it wasn't going to fit on the screen. Okay, that's pretty much the reason for this. You can obviously use any JVM language to do this because it is called Java. But effectively what you are going to do is you have to go to a provider, you have to say give me a byte channel. And you can give it different options. So for instance, this one we're just going to read files, so I am going to put my option in there. And the new byte channel actually takes a set as the second parameter, so we just convert it to a set. Once you can just think how much lines actually I have to start to write if I want to put things into a set in Java and then put it in there. So for the purposes of this rest of this talk, a lot of things might be in Groovy just to keep it simple to show the intent. Then you have to allocate a byte buffer because NIO2 does everything in byte buffers. It has a couple of static methods on it to allow you to create them. So I'll just allocate a byte buffer, say 10 bytes, and then I'm going to write some things into that. And you can tell it the length for that. Obviously, typically you might want to tell it how many bytes you want to read, etc. But that is pretty much the kind of code you have to do to read and write in NIO2. The problem is this is so low level. Anybody recognize that code? Okay. That's plain old C code, all right? It's nearly the same as that. That's plain old POSIX C code. So this is effectively the level that NIO2 gets in at. It's pretty much the lowest level of abstraction in Java to actually access the file system. Which means that to really make it useful to understand, it's great to put actually better libraries on top of it, which I'm not going to talk about. But for instance, like a Groovy VFS abstraction on top of something like that will make people's life a lot easier. Or if you can, for instance, extend Guava or something like that as well to do that, it would be much easier. But you have to remember this. If you're going to write a provider for it, you have to remember that as well, because it's going to be pretty low level. So some of your code is going to be very, very low level. Now, the other thing is, and I hate this about it, it's got two things on file systems. The one is called new file system, and the other one is called get file system. And that is a specific Java doc that comes out of it. The one will throw you an exception if the file system exists. The other one will throw you a file exception if the file system doesn't exist. You have no option of doing this in a single go. So you end up writing code like that. Try the one. If it doesn't throw exception, try the other one. And then at the second one throws exception, you know the file system doesn't really exist. But you end up writing things like that. In terms of programming experience, I think it's a failure. But you have to live with that. Once again, a higher level abstraction I can take care of things like this would make life easier. Okay. And now I'm going to start making it a bit interactive now. So you can think about writing a file system. But you have to, there's a number of hard questions that we're going to have to answer here. So here's the first one. You have an FTP system. They're on the same server, but they have different credentials. Do you think it's the same file system or it's a different file system? Who wants to take a guess? Not a guess. Actually, I want to say there's no right answer here. Who wants to motivate a point of view? Yeah.
I would say different file system. If you want to hide the information of the credentials.
So you're going to say it's a different file system, so you can hide the information of the credentials. Does the credentials make any difference in terms of the access?
No.
Okay. Anyone else? Maybe I had too many mojitos last night. Okay, now there's actually not one right answer here. This is the kind of things you have to think about, because you could say, this is fine, I'll treat it as one file system, and I will let the remote side sort out what the access is. But you might say, hold on, for instance, this is FTP, the remote side might actually already hide files from me, depending on the credentials, so I want to treat it as two. So it's a choice you have to make. And this is the kind of choice you might have to make in many of these kind of implementations. You might have to provide something like an option there which allows the backend to make a switch, but it's up to you. Ooh, okay, I'm going to move a bit quicker because I want to show you some code. Right, okay, concurrency is the next problem. You are used to file systems being concurrent, because multiple people can use the file system, etc., can access it. Now, the thing here is to create new file systems, you might be hitting it concurrently in your code. So somebody who implements this have to make sure there is some kind of concurrency control, some kind of synchronization. A typical implementation might use a registry underneath to actually register different file systems. But you have to also remember, yeah, that your focus is actually protecting the objects in memory, not the remote file system, because the remote file system should normally take care of itself. But you want to actually have the abstraction that sits in memory actually protected when you go to have concurrent access. Just another little thing to take care of. Here's another question. If you do remote connections, do you do one connection per file system or multiple ones? No wondering? Again, there's no right answer in this. No wrong answer either. It depends on the protocol, I guess. I mean, certain protocols do quite well with putting things on a single connection. HTTP can do that. FTP, because it's a split protocol, which uses a data channel and a control channel, it opens data channels for every connection, so you have to control that. So you have to think about things like that, network access, etc., and then you have to think about, should I implement queuing requests in the back for a specific file system? There's different kind of things. It's a lot to think about. And then there's local caching. I mean, obviously, if I'm going to pull a file from a remote site, I don't want to do it every time. I might want to cache it locally. So now you have to think about what kind of local cache are you going to implement, and how long it's going to live in that cache. So there's all those kind of things. There are good implementations of caches out there. You just have to decide on one which you can use locally. But it's all things to take care of. Obviously, if you're just going to pull stuff out of a zip or a tar, you're probably not going to care about caching. But if it's remote, you have to care about caching. So that's the kind of things to take care of. And this has to be hidden from the person that actually uses NIO on the top, because there's all the abstraction at the back end. And then you have the question of which language you're going to implement this in. So obviously, a lot of people, Java is going to be the default choice. It doesn't really matter. You just have to think about a couple of things. You have to think about performance. Sometimes you're not going to care too much about performance, because I just want to get this to work first so I can understand what's going on. And then I will about optimizing it later. So you might, for instance, implement in a language you think is less performance, but you understand it better. It's up to you. But then you have to think about things like runtime support. For instance, if you're going to implement something in Kotlin or GROOVY, it's going to you have to pretty much also pull in the GROOVY or the Kotlin runtime library. So you might think, okay, well, that's a problem. I don't want to do that, which is fine. Especially if you implement something you can do purely in Java, that's fine. If you're going to start thinking, well, I am actually going to use FTP, for instance, I want to implement that. I'm not going to implement the whole FTP protocol myself. I'm going to use a third-party library. you're already pulling in a third-party library. So, well, you could potentially just pull in another runtime as well. I don't think there's much of a difference. But you have to think about certain implementation languages as not very suitable for this because they do data marshalling. So probably doing this in JRuby is probably a no-no. Probably even Scala might not be even a good option. But as things, all kind of things you have to ask. So I'm just going to mention a couple of things before I get to showing some code. So recommended practices here is a couple of things I think people should do. And one library I want to touch on is HTTP Builder NG. That's a great little HTTP abstraction. But what it actually does is says we're not going to use one third-party library. We allow you to choose which one you want to use. And it actually either uses the core Java HTTP URL connection, or it uses HTTP components from Apache, or use OK HTTP. Now, people that use OK HTTP normally already rave about it. But what this actually provides you is the person who actually has to use your code might already be using one of these free solutions in another part of the project. So they're not bound to pulling in yet another artifact. They can actually already reuse the artifact. So it's great to do this couple of things. And then you just, and these things are pretty much just named that way. If you want, for instance, want to use OK HTTP version of this, then you just say HTTP builder ng dash OK HTTP. And it will pull that one in, and then obviously it has a normal kind of abstraction above it, which means you actually writing code against it doesn't notice it, but you can select which artifact to use. So this is one good thing to actually remember if you implement a provider, is to do this as well. The second thing is actually just naming it. Based upon that, I just suggest you name something as your artifact, or something like NIO. Give it a protocol name, just the word provider, and if you use an implementation specifically, give it a name so that people actually know how to pull it in. And then this is a nice kind of other thing to try and do if you can. Apache Commons VFS does this kind of thing. You can say like jar FTP or zip FTP. So what it actually does is it abstracts this in one go. And it says, I'm going to go to that FTP site, collect that jar, I'm going to look inside it, and I just want to pull out a manifest file. So if you can actually implement this in a provider, this is actually quite great. So you actually have to know, I'm seeing this as a double barrel scheme. I'm going to pull my part out, I'm going to defer to something else first, and then I'm going to do the appropriate connections in the back, and then do my abstraction. So, but this gets complex to implement. Just before I actually move on to something else, so the other kind of two things, just don't spring unsurprising behavior on the user. Try to do things which I would expect from the local file system to be roughly the same. Also, just document any behavior specific to a file system. Like, for instance, with FTP, you would say, well, you have to do this to control the number of connections, etc. And please don't do this alone. You will see why in a minute or so. Writing this kind of providers is actually very complex. If you just looked at the hard questions already, you will need somebody else to talk to. So it's better to actually write these things as a team. So actually, I hope coming out of these things, maybe one of you say, oh, this is like an interesting challenge, I want to try this. Then we can do it together. There is a thing going on at Apache Commons team, or the Commons FS, to also probably do this, but I don't know how that will go. It's always useful to do this kind of things, because you can do it outside of this project, because once you've written a provider, anybody that uses NIO2 can drop the provider on the class path and it should work. So, if you want to implement NIOFS, this is actually the minimum classes you have to implement. You have to do a file system provider, a file system, the stores. A file store is actually something which you can equate to, like on Windows. You have a file system, but it's actually multi-rooted, so it's a C and a D and an E, so it's possible you have multiple file stores for a file system. So in Linux and Mac, you don't really care about that, because the file system already abstracts it away from you. So in certain cases, you will always only have an instance of a single file store per file system. In some cases, you might have multiples. You have to implement a way of abstracting the scheme and breaking apart to interpret it, and then you actually have to create this byte channel as well, which is the hardest part of the whole thing. And then finally, you have to tell Java or the JVM how to find it, and we get to that. So, oh, I've got the wrong one on there. So let's go pop out of there for a moment and see if we can get to some code. See if I can get this to properly work. Right, can you see that? At the back? Great. Okay. I've just started doing some stuff here, and there's not much. I'll see if I can get the file systems on the side. Do that first. Actually, just to be simple, we're going to go just do a couple of things here in the last couple of minutes. I have, how many minutes? 10 minutes left. Yeah, 7, okay. I'm just going to pop through this very, very quickly. The first thing is the file system provider, but before we get there, I actually want to grab something else first. This one. How do you get out of presentation mode? I can never remember. Ah, there it goes. Okay. I wanted to pop into something else. So the one thing you have to do is you have to drop something into meta-inf services, and you put the name of your class in it. This is the file system provider. This is the first thing you have to do. Then you actually have to go and implement this file system provider, which is the next thing. And I've just decided I'm going to try in 7 minutes to show the starts of actually having to do a RAM file system. So what we have to do is implement this. And the moment you get that, no, come on. There's a lot. Okay, this is the start. This is everything you have to implement just to get the file system provider. Now you're getting an idea why people don't want to do this. It's a lot of work. It takes a lot of time. Once again, don't do this alone. Okay, come on. It's generated it. Okay, the first thing you have to do, you always have to tell it a scheme. So, as I said, I'm just doing this GROOVY. It's going to be a bit quicker to type this. For instance, I want to say this is a RAM file system, and it's going to be recognized by a scheme called RAM. Okay, so you have to put that in there. The very, very first thing. Now let's see if this loads. So I have got a test written for it. Everything else, that's my simple test. Actually, I told my test to load RAM foo for a reason. Okay, so I am going to change this. Let's close that. Let's call it RAM foo. Okay, that's my basic test. I want to make sure if I just run the simple test, if I put a jar on a class path, it has to load it, and it has to be a RAM file system provider. Let's see if this works. Obviously, it doesn't want to load that other one. That shouldn't be there. When you start doing this the first time, it's useful to write simple code like the second line, just to help you understand how things work. You say, oh, it didn't load anything else that didn't exist. Okay. So let's have a look. Okay, and can you see that as well? Let's see if we can get the screen cleared. So I am going to build this with GRADLE. Okay. Let's clean it first. Actually, let's break it first and just call it foo. Ooh, that actually worked, which is a problem. To make sure this code actually do work. Go back to that code. Okay, it says it worked. I wonder if it. I know what it is doing. Okay, let's just do that and load it. So, see, break it first. Make sure this test actually executes. Oh well, Hubert is in here, and he's going to do Spock later today. If you don't use Spock, I suggest you go to it because that's the unit test I'm using at the moment. I think it's not picking up my unit test. It's not picking up my unit test. That's what's happening here. Never trust a test that you've never seen failing. Yes, let's do that. Good. We know that test is there. Okay, let's break it again. And this is what I don't like about this. My MacBook's touchpad sometimes just goes crazy. And then I have to switch to a mouse. So I always have the mouse on standby. Okay, let's try that again. Let's see if it fails if we run that. Okay, I'll do one more. So, okay, you can see that fails. And if I say RAM foo, it should now pass. Okay, so yeah, that's pretty much the first thing you will need to do, and that's just the start. So you have to implement all of these things, and the first thing you actually really have to do is create a new file system. To create a new file system, you actually have to go implement a RAM file system class. And once again, once we take this off, so this is actually why it's quite useful to have something like IntelliJ, which generates a lot of methods for you, and put some at least non-working code in there, but which at least will compile. Sorry? What? Oh, I can't even see it here. Yeah, thank you very much. Don't do this alone. All right, let's try again. Okay, a bit less, but still a number. Okay, so one of the tricks and this is once again very, very simple, but you probably have to do something like, well, before we do that, let's put a constructor in here. And generally, a good idea is to put the provider in there. So that the reason for that is you have to implement this method at some stage. So you have to put it, tie it back. So that's the next kind of thing you have to implement. And I'm just going to pop down. I'm going to leave that like that, because we're pretty much running out of time. You have to implement like how to do a close on it, and obviously the normal is open check. Some of these things are simple. So it is possible to abstract some of these things. You can write more of one of these into an abstract layer. So I think it's even a good opportunity to write another library here that can do a lot of the abstractions for you. Because the next thing you really have to do as well as do this is actually to parse the scheme. Right, so for instance, if you want to implement a RAM file system, we might just say RAM is good enough to what you're going to call it. But maybe you want to say, I want to implement more than one RAM file system in memory, make it easier for people. So the first thing that follows the scheme name might be effectively a name of a RAM file system. So I might have say example 1, example 2, and they might be 2 different file systems. So I might want to do something like that. So I have to write something to actually break up the URI and then apply some intelligence to that. Another thing that you might want to do is you might want to allow it to parse query parts of a URI to do additional things for an option. So there are kind of things that you want to put in there as well. So there's a lot of kind of things that you have to implement. So we just have to kind of pop in there quickly. If you implement a path, so that nice little thing that you normally use, that's called the path, it comes with a lot of pain for somebody who does it. So you have to implement path as well. All right. You can see why it's a lot of work and why a lot of people simply do this. And this is why I'm going to come back to my old point, is don't do this alone. So if you're interested in trying this, because it's really useful, I would be totally willing to work with somebody to actually do this. This is one of my pet projects to do. Because since I've done GROOVY VFS, I actually wanted to get GROOVY VFS to eventually work with NIO2. So in order to get it to work properly, I need proper providers. So I'm always happy for people to work with this. I think I'm going to stop on this and just allow you to answer some general questions.
Well, the first question that pops to my mind would be, is there any library that that already implements.
There is nothing that I am aware of in open source that does.
So you have to go through this hassle.
We have to go through this hassle. There might be in one of two open source libraries that have done it, but only for that library, and it's not extracted in a way you can use easily. If there's something else in NIO2 called file type detector, that's implemented. I've written that, and somebody else has done it well. And actually, I'm going to push my one back into Apache Ticker because it uses Ticker underneath, and it's actually a very good provider for that. But that's file types. That's easy. You don't find the same kind of things for providers. I can't even see that. No?
Seems so.
Okay, well, thank you. Gracias, gracias.